All right, this next part is hugely important. This is pretty much, when I give this test paper and pencil, this picture is the first entire page of a test if this test is done on paper and pencil. So I do want to note, if you looking at the solutions to the next two pages are actually listed in 1.6.5, but it's the same problem. I just merged the two notes together into 1.6. So on the solutions, to see the solutions for this, you are going to have to look at a separate packet. It's listed right there in Canvas for you. Okay, so really there are questions on both these two pages, page 4 and page 5 of this packet, and all of them pertain to this graph. So because I'm making videos, I'm really going to answer all of the questions for the next two pages looking at this single page. So for the answers for page 5, look at those posted solutions in Canvas, but I will talk through all of the answers in page 5 in this video right here, right now. So what's the idea? I should be able to give you a graph, and you should be able to tell me where is it continuous, where is it discontinuous, and why, okay? So remember, continuous means graphically we can graph it without lifting our pencil. And continuous as a definition needed three things. The function had to exist, the limit had to exist, and the function and the limit had to be the same thing. So if you are telling me that the function is not continuous or it's discontinuous, you have to state exactly one of those three things. And that's what this first note is trying to tell you. It says if x is discontinuous at a point, say x equals 3, for example, you must state why it is discontinuous. And there are only three things that I'll accept on the test if you say it's discontinuous. The first one is you have to say the function doesn't exist at that point. And the way that you do that is simply write, remember we're talking about x equals 3, so you would simply say f of 3 is undefined, or f of 3 does not exist. Okay? The second thing is the limit must exist at that point. So if it's discontinuous, you would have to say the limit as x approaches 3, and you do need to plug in the number 3 there, of the function does not exist. The last thing is the function is not equal to the limit. So you would simply write it's discontinuous. Why? You would say f of 3, which exists, is not equal to the limit as x approaches 3 of f of x, which exists. So you're saying the function exists, the limit exists, but they're not equal. So those are the only three things that you could put on the test. You could put any one of those three things as long as it pertains true to the problem. Okay? No other answers will be accepted. So if you say it is discontinuous and you don't put one of these three things down, then I cannot give you credit. Okay? So it says, given the graph of the function below, evaluate the following limits. No work needs to be shown for the limit questions. If a function is not continuous at a given point, you must state why using the definition of continuity. So we're going to bust this up at x equals -5, -4, -1, 0, and 2. And let's go ahead and talk through every single one of those examples together right now. Let's start with the one that's on this page. The example is x equals -5. Remember, x equals is a vertical number, a vertical line if we're trying to graph x equals. So here's x equals -5. Right here, there's my vertical line. This is the value that I'm looking at. And what I want to do is I want to analyze my function. Notice, if I come from the left, my limit is the y value approaches 3. If I come from the right, the y value also approaches 3. The function is defined at that point, and it's equal to 3. So those are the questions that you see right here. From the limit from the left, what did I get? Well, the limit from the left, the y value approached 3. The limit from the right approached 3. Since those two are the same, I know the limit exists, and that's what it is. The limit is 3. Then I looked at the function value. It was defined there, and it was also at 3. Now, since these two are the same, since the limit and the function are the same, I know that it is continuous at that point. Okay? So if the limit from the left and the right are the same, the limit exists. If the limit and the function are the same, it is continuous. All right? So that's the answer to those problems. Now let's think about those exact same answers or those exact same questions at a different x value. The next one I'm going to do is at x equals -4. Let's look at x equals negative 4. So I'm looking at the blue line on the graph that I just drew. Here's x equals negative 4. Well, let's look at that limit from the left. If I was doing the limit from the left, my y value approaches 0. So the limit as x approaches negative 4 from the left of this function is 0. The limit from the left is 0. What if I came in from the right? Well, my y value approaches negative 3. The limit from the right is negative 3. So again, from the left it approaches 0. From the right it approaches negative 3. Though those two things don't agree with each other. And since the left and the right don't agree, here we would say the limit as x approaches negative 4 of f of x does not exist. The limit from the left is 0. The limit from the right is negative 3. But the limit, because they don't agree, does not exist. Function value, where's the closed circle? Well, the closed circle is defined at negative 3. So f of negative 4 is negative 3. So let's summarize that again. The limit from the left is 0. The limit from the right is negative 3. The limit at that point doesn't exist, and the function is negative 3. The next question asks, is it continuous when x equals negative 4? The answer would be no. Why? Well, graphically, we can look at it. It doesn't meet. We have a jump, right? We can't draw it without lifting our pencil. So the answer is no, but we have to be very, very specific as to why. Why is it not continuous at x equals negative 4? It's discontinuous at x equals negative 4 because the limit as x approaches negative 4 of this function does not exist. That is why it's discontinuous. It's discontinuous at x equals negative 4 because the limit as x approaches negative 4 of f of x does not exist. We can't say, remember, it has to, does the function exist? Yes, it does. Does the limit exist? No. Okay, it's discontinuous. All right, let's look at the next one. The next one I want to look at is, how about x equals negative 1? Here's x equals negative 1 here, all right? Let's do our limit from the left, limit from the right. So limit from the left, I'm coming in there. What y value am I approaching? Well, the y value I approach is 0. The limit from the left is 0. Let's look at the limit from the right. What y value am I approaching? Well, it's also 0. So the limit from the left is 0. The limit from the right is 0. Again, let me color this in real quick for you. This is the line that I'm looking at. I apologize. X equals negative 1 is the line I'm looking at, all right? So the limit from the left is 0. The limit from the right is 0. So that means the limit at that point exists and is 0. So the first three questions, parts A, B, and C, would be 0, 0, and 0. The fourth question, though, is where does the function exist? Well, look in that green line. Do you see a black dot anywhere? And the answer is no. So what does that mean? It means the function is undefined, or the function does not exist at that point. Okay? So the function is undefined. The function does not exist at that point. All right, so the next question is it continuous? We'll go through your three rules. Function must exist, the limit must exist, and they must be the same. Well, we just discussed that the function is undefined. We know that f of negative 1 is undefined. And because the function is undefined, we would say it is discontinuous. Okay, so it's discontinuous because the function is undefined at that point. It missed the first one. All right, let's look at the next one. How about let's look at x equals 0. X equals 0 is the next thing I want to look at. Okay, x equals 0 is the y-axis. Let's look at our limit from the left, limit from the right, limit at the point, function value, and is it continuous? So as I come from the left, what's happening? Well, my y value is approaching negative 3. So the limit from the left is negative 3. As I come down from the right, what's my y value approaching? It's also approaching the y value of negative 3. So left is negative 3, right is negative 3. That means, because those agree, the limit at that point is negative 3. So the limit as x approaches 0 of this function is negative 3. The limit exists and it's negative 3. Now let's look at the function value. Is there a closed circle? Well, yes, there is a closed circle. It's a closed circle with a y value of 1. So that means f of 0 is 1. Okay? So the limit exists, it's negative 3. The function exists, it's 1. The question is it continuous at x equals 0? Well, does the function exist? Yes. Does the limit exist? Yes. But are those two things the same? No. So is the function continuous at x equals 0? The answer is no. It is discontinuous, O-U-S, okay, because the limit as x approaches 0 of my function is not equal to the function value at 0. So that's why you would say it's discontinuous. It's discontinuous because the limit as x approaches 0 of f of x is not equal to f of 0. The limit's not equal to the function value at that point. So we need to include that 0 there. All right, the next question would be at x equals 2. Let's look at x equals 2. All right. So what happens as we come from the left? I'm growing without bound. My limit would be approaching infinity. So from the left, the limit from the left as x approaches 2 is infinity. The limit from the right, same thing. That looks like it's going up towards infinity to me. So the limit from the right is infinity. The limit from the left is equal to the limit of the right. They both grow without bound. They both approach infinity. So the limit from the left, limit from the right, go to infinity. So that means the actual limit at that point exists and goes to infinity as well. So the first three answers, A, B, and C, would be infinity, infinity, infinity. The limit from the left is infinity, limit from the right is infinity, limit at that point is infinity. Okay, so what happens then at that point? Is there any defined point? Is there any closed circle there? The answer is no. So what does that mean? That means the function does not exist. So the function is undefined at that point. The function does not exist at that point, or the function is undefined at that point. So that's the answer to part D. It would be undefined. The third question, again, as always, is it continuous? And the answer would be it is discontinuous. No, it is not continuous. It is discontinuous because f of 2 does not exist, or f of 2 is undefined. Okay? All right, so that's how we look at this graph right here. That's how we could figure everything out, looking at the points. We have very, very nice examples. We have one where it was continuous at the point. We have one where it was discontinuous because the limit doesn't exist. We have one that's discontinuous because the function doesn't exist. We had one where it was discontinuous because the limit existed, the function existed, but they were not the same. And then this last example is just an extra example of where the limit existed, but the function did not. So that's why it was discontinuous. So a wonderful graph there, kind of testing all three parts of the definition of continuity, which things can go wrong. Hope that helps. And again, for the answers written down, if you want to see those answers written down, look at the solutions for 1.6.5. That'll give you all the answers to page 5, which is the next page on the solutions.